Welcome everyone to the Greener Hub webinar series. My name is Evelyn Zuniga and I am one of the communications officers for the Greener Hub project. For those who have not been here before, the Greener Hub project officially started in September 2022 as a coordination support action of the European Commission under the Horizon Europe program, and it currently represents 15 ERANETs, co-funds, and self-sustained initiatives in the field of agri-food and biotechnology. With this serious club that we did from October until December, this is the last one, we wanted to focus on the topics that are around sustainable agriculture. And we have talks about mixed farming systems, mitigations of greenhouse gas emissions, sustainable farming, circular food systems, etc. It has been like we have had very interesting talks with our researchers. It's been really good. Just a housekeeping announcement. Feel free to type your questions in the Q&A and the chat section. I have enabled the chat section for everyone to write your questions. And I'm going to do my best to address as many questions as possible with the time that we have, that is 1 hour. And if at the end of the session you have a question for one of either of the presenters, you please address the speaker on the question. Okay, so to start, we have two panelists today, Dr. Marc Moraine and Dr. Mihaela Balanescu, and we're going to open our presentations with Dr. Moraine. Let me share my screen here 1 second. And this one. Dr. Moraine is a research engineer at the French National Institute for Agricultural Research, INRAE, and his research focuses on agronomy and agroecology on the crop-livestock integration at territory level and the diversity of farming systems, complementarities and synergies at the local level. And today his talk is going to be about circularity in reintegrated crop-livestock systems at territory level, pathways and limits for transitions. So thank you very much, Dr. Marc Moraine, for accepting our invitation to present in the Greener Hub series. And I am going to stop sharing my screen so you can start sharing your presentation. Thank you so much.
Okay, thank you very much. So I will try to share my screen so that you can see it properly. Is it okay for you?
Now it's in presentation mode, it's perfect, yes.
Cool. So yes, my name is Marc Moraine. I'm working in a research unit in Montpellier, INRAE Montpellier, which is a French National Institute for Agronomic Research. And I'm working with several colleagues around the questions of crop livestock integrated systems at local and territory level, and how to develop it and how to support the agroecological transition around this integrated crop livestock systems. One of the main projects that we are developing is called Sagittaire, and I will talk about it later. So who we are agronomists and scientists in animal production mainly, but we are also trying to collaborate with a team of colleagues in social and human sciences to be as far as possible in connections with real problems and real conditions of development of new practices in farming. So, for example, we are working in this Sagittaire project together with crop farmers, livestock farmers. Here we were doing the wool harvesting with a livestock farmer, and wine makers. So you can see that we have lots of sunny weather conditions around Montpellier. So the field work is not so bad. But talking about circularity, crops and livestock, and the people that are developing and supporting those kind of circular systems, I will say that I will try to develop some of the main ideas in the state of the art and the projects that we are leading today around the three questions. Why should we close the cycles, the nutrients and organic matter cycles? Who are the persons in charge and really involved in this nutrient cycling, and how to make it better? And of course, what are the limitations and the barriers to develop much more circular systems? So taking a look back in the past, during the 19th century and until the 19th century, around the cities in Europe, there were production belts for milk and vegetables around cities, very close connection with consumers, with the functional complementarities between the livestock production for milk and meat and the vegetal production for vegetables and also cereals, but cereals were a bit more remote from the cities. And for example, in historical descriptions of rural systems in the region of Lyon, a big city in France, you can see that there were really common complementarities between the vine systems, vineyards, and the goat production system. So goats were feeding on the vineyards, and the goat manure was used to fertilize vineyards. And this was developed all around France and probably Europe over centuries. What has changed is during the Green Revolution after World War II, the specialization, the substitution of organic matter and organic inputs by chemical inputs. Oh, sorry. For example, in the Mediterranean production of wine, the sheep grazing was very common, and it has been substituted by the herbicides. And the shepherds disappeared from the plain of Languedoc and Provence when the chemical herbicides appeared. But also the supply chains and the farm structures have changed a lot and become more and more concentrated. You can see that in agricultural landscapes before the Green Revolution, the farms were really small and scattered, including a lot of semi-natural areas and semi-natural vegetations, which were completely destroyed and disappeared after the reorganization of farms and the very large setting of plots, agricultural plots and farms. But the problem is, of course, the end of the closing of cycles of carbon, nitrogen, and phosphorus. Nitrogen is mainly produced by synthetic reactions now, using a lot of fossil fuel energy. Phosphorus is a fossil resource extracted from mines, mainly in Morocco. And carbon is, of course, extracted from agricultural soils and concentrated in the atmosphere. So a lot of sustainability challenges, but the thing is that the agricultural sector and the crop and livestock connections are nowadays embedded in international trade, with a very small number of countries exporting feed for the rest of the world, so in North America and South America, and a very large disconnection between crop and livestock production areas, leading to this uncircular, linear utilizations of nutrients. Lots of colleagues are working on the scenarios of crop livestock reconnection, and the place of this connection between crops and livestock in sustainable food systems that are using both local and renewable resources, such as semi-natural areas, grasslands that are not useful for human consumption, and also including the use of co-products, industrial byproducts, to feed animals, so that we can define what von Zanten et al. Describe as low opportunity cost livestock systems. It means livestock systems that are produced and fed without high impact on natural resources, on ecosystems, and on the feed-food competition. So that's mainly the approach in which we are working nowadays. And the question is how to switch from the current situation of coexistence between animals and crops, which are exchanging and connected through international markets, to more complementarity, which means temporal coordination in time with, for example, straw and manure exchanges between animals and cereal systems, and as far as possible, going to stronger level of coordination, spatial coordination, with integration of grasslands within the crop rotations and cereal systems, with direct grazing of animals on agricultural plots, leading to local synergy, or as far as possible again, to territorial synergies, valorizing the diversity of livestock, crop production systems, and grazing areas, pastoral areas. But the question is how to do it. How to do it, and with who, which type of farmers, which type of collective organization. An example that is already existing in France is the connection between really concentrated livestock production areas, such as Brittany and Normandy, and crop areas from the Parisian basin. There is an industrial group, an industrial company called Terial, which is working on this circular economy to gather and harvest the manure from big livestock farms, to process it into smaller organic fertilizer, and to transport it and sell it to crop farmers, specialized crop farmers. But the overall cost, environmental cost, is still existing, because there is processing of manure. The livestock farmers are not changing their practices, and also working with industrial and international supplier for feed, and the crop farmers, sorry, are still using a lot of inputs and pesticides, even if they are working with these organic fertilizers. So industrial supply chains to reconnect crop and livestock are not the very best option, or at least it doesn't meet the challenges of agroecological transitions. On the other side, there are initiatives such as sheep grazing in cereal farms in the areas of Paris, surroundings of Paris, a project called POSIF, which is working on developing living soils and agroforestry in cereal systems, in specialized cereal systems, but through the connections with shepherds and livestock systems, which are mainly ovine for meat, so sheep and ewes, grazing on cover crops or crop residues. There are also middle-scale initiatives, such as quite big farms that are, in fact, several farms grouped together to produce diversified crop rotations, livestock units such as bovine with meat production, and the introduction of methanization, biogas units to valorize and to make the best use of animal manure and of some diversification crops. So there are existing initiatives to reconnect crop and livestock systems at territorial level, but the problem is that the massification and global transition are really difficult to implement because of what we call socio-technical lock-ins. For example, at different level, at farm scale, but also community, local ecosystems, but even at government and global level, we have stronger limiting factors, barriers for this development of reconnected crop livestock systems, such as food safety regulation, the problem of manure handling in the ecosystems, also social aspects such as differing motivation and expectation between crop and livestock farmers. And for some areas and some farming systems, the question of labor shortage. All these transaction costs have been studied and described in an article from 2018 by Masayasu Asai and colleagues, in which we were working on this limiting factors for crop livestock integration. Going on the farmer groups on Facebook, I've picked some memes, some humoristic pictures showing that there are really different visions, different perceptions of the work of farmers. When you are livestock farmers, when the winter comes, you are going to the cows to feed them in the snow, where in the same time several farmers are playing on Farm Simulator online. This is quite caricatural, but it's a kind of joke that farmers are doing together. And it still determines the coordination, the possibility of coordination and discussions between farmers. There was a PhD in 2017 to describe the different coordination modes between crops and livestock farmers, and also articles by a colleague called Julie Richaoui, showing that there is a very large diversity of coordination types. It can be neighboring farms, two farms, one crop and one livestock farm. It could be several farms grouping together to exchange and make the best use of local resources. And it could be larger groups or even cooperatives that are structuring the exchanges, so grouping the projects and the offer and demand, and organizing a very localized market. Which innovations to unlock this crop livestock integration at territory level? In the area of Montpellier, I'm working with a group of farmers that are supported and supported during their settlement phases by the local communities, by the municipalities, and for example, the city of Montpellier is also supporting this initiative to diversify what was historically wine production domain to make still wine production, but with a very important social aspect of reinsertion of workers, but also to develop organic vegetable production and livestock production with connections between, for example, the milk production, goat milk production and goat cheese production, the feeding of pigs in open yards, and the fertilization of vegetable fields and grazing in vineyards. Coming on this Sagittaire project, which is a project developed since 3 years in the Minervois region, so in the southwestern France under Mediterranean climate, sorry. In this area, we have several technical innovations, such as the grazing of vines and crop fields, cereal fields, with coordination between shepherds, winemakers, and cereal farmers, and other type of diversification supporting the organic conversion of fields, cereal fields, and vineyards to integrate further production within the crop rotations. I don't go into the details, but technical organizations, technical practices are really sophisticated and really designed to manage the high complexity that we have in Mediterranean climate to adapt to climate change and resources depletion. The research work carried with local partners made us work on a scenario of redevelopment of livestock units on the territory of Minervois, and we discovered that there is quite an underestimated potential for feeding animals on this territory, but the feeding potential is very, very different from one season to another. In winter, there is a great potential on the vineyards, to graze on the vineyards. In spring, there are grasslands that could be used for to feed animals. In summer, it's really much difficult, but there are semi-natural areas and pastoral lands that could be useful for animal production, and that could meet local challenges, local sustainability challenges, such as prevention of fire risk and keeping the ecosystems and the areas open to preserve natural habitats for biodiversity. So we tried to design scenarios to meet these challenges at local level, and for this, we integrated the knowledge and point of views of diversity of local stakeholders. Finally, the challenge is to reconnect crop and livestock production. There is a synthesis by Garrett et al. In 2020 showing that we both need evolution of the landscape, the socio-technical landscape, and the development of technological local innovation niches. That's more or less what we try to do in this Sagittaire project. The question remaining is which combination of crop, pasture, and livestock according to local conditions, and here we need to be very precise and embedded in local condition, how to maximize the low opportunity cost feed, so what is really efficient to use for feeding animals, what are the trade-offs, antagonisms between ecosystem services and the feed or food production, and what could be the conditions of coordination between farmers and local stakeholders. So how to support this reconnection and these transitions towards a more integrated crop livestock system. This led us to research avenues for the future, technical questions in livestock system management, but also in the way cropping systems can be diversified and introduce the livestock requirements, how to design and foster the crop livestock system considering the local challenges, but also the technical, legal, social, organizational issues. And for this, we need to develop more interdisciplinary and participatory research. And still, policy measures at different levels are needed, strongly needed to overcome the important barriers that we have. I've put this picture to remind you that one of the Hercules' tasks was to clean up the barns of the King Augeas, because it's still a challenge to do this at different levels. So thank you for your attention. We have lots of references, scientific references, and projects connected to this question, and I can share it with you.
Thank you very much for your presentation. It's great to know that so many things are being done on this level to be able to integrate these systems. So I have a question. So I want to remind people that they can use the Q&A box or the chat box to put your questions. But then in the meantime, I have a question. So you mentioned that there were like food safety regulations that are some kind of problem. So what specifically, like what regulations are these that are kind of like making this harder for them to have like an integrated system?
For example, we have the regulations around biosecurity for animals that are grazing or that are outside, for like open air pig production. This is highly constraining livestock farmers, and some of them are not convinced or abandon even this kind of livestock management because of this regulation, because they don't want to be out of law. So they stick to the industrial model of raising animals in buildings, and so they cannot, for example, go to graze to vineyards or orchards or cereal areas because of this biosecurity regulation.
We have a question here on the chat. It says, is Terial operating profitably serving local farmers?
Well, I I wouldn't say so. I think it's for some of them really useful. It's a service of supplying organic fertilizers. For example, when cereal farmers or vine production farmers would try to convert to organic farming, then they need to switch from mineral fertilizers to organic. But some of them don't want to redesign their production systems. They just want to substitute uh, chemical inputs to organic inputs. And for this, the proposition of Terial, but also other companies are doing that kind of uh, business. It's useful for them, and it serves the organic conversion of some farmers. But this is like a very short-term solution, because in the specialized crop of our vineyards production, we have this organic matter problem and fertility problems in soils that won't be solved by this kind of organic fertilizer, because it has a very low level of organic matter. It only brings nitrogen and phosphorus from organic sources. So we still need to develop a diversified system, cover crops, and direct grazing or manure spreading on fields. I make it short, but this is the idea.
Yeah, we have another question from Owen Carlton. It says, to what extent do you involve local non-farming communities in your research, and how important is their role in the local community?
When I'm speaking about local stakeholders, I'm mainly talking about the land management agencies or structures that are involved in local development. For example, there are associations for new farmers, farm settlement. There are the Natura 2000 programs, stakeholders, so the animators, facilitators of those programs around biodiversity, but not so much consumers. In the south of France, at least, it's difficult to integrate the local consumers and citizens in that kind of project. Maybe that could be possible, but it's at the day-to-day very difficult to conduct. But I have knowledge of other programs, other projects. For example, in the Rennes area, in the Rennes city area in Brittany, there is a program called Terre de Source, trying to redevelop more diversified systems to support organic conversion of farms and to integrate the consumers within the process of designing sustainable farm and food systems at local level. So that exists, but not in our area.
Okay, thank you very much. This is great research you have going on here, and
thank you very much.
Yeah, and we are going to move now to our second presenter. Thank you very much, Marc, for your presentation, for accepting. We are going to move to Dr. Mihaela Balanescu. One second, let me share my screen here. Share. Okay, now joining us is Dr. Mihaela Balanescu, who is currently a senior researcher at Beia Consult International, and her research is focused in the field of greenhouse gas emissions, inventory and projections, climate change, air quality assessment, mathematical modeling of technological processes, statistical analysis, environmental risk assessment, and environmental technologies. Today, Dr. Balanescu's talk is entitled Challenges and Solutions for Greenhouse Gas Emission Mitigation for the Mixed Farming System Across Different European Climates, which is part of the Solution for Farming project. Dr. Balanescu, thank you very much for accepting our invitation to present. And now the floor is yours. I'm just gonna stop sharing my screen so you can start sharing your screen. Thank you so much.
Thank you. Thank you for the presentation and introduction. And also I want to thanks all of the participants for being here. And let's hope that will be a nice meeting and nice sharing of information. So I will start to share my screen. Okay. Okay, can you see my screen?
Yes, thank you.
Okay, just a moment, like this. I will present some challenges and solutions from greenhouse gas emission mitigation for the mixed farming systems across different European climate. As I will present mainly the challenges that we face and we try to address in the solution for farming project. My presentation will start with a very brief presentation of the project aim and objectives, and then I will present our pilots and preliminary results that I think will be more of interest of everyone. First of all, some words about the project. We are 5 partners from 4 countries, from Romania, Finland, Poland, and Spain. And as you see, we already are from various different type of climate. First 2 partners, it's Beia Consult International, that it's an SME focused on ICT. The second one, it's the University of Agricultural Science from Bucharest, from Romania. We have partners from Finland, from the north of the Finland, from University of Applied Science in Oulu, close to the Santa Claus. So a completely different type of climate. From Poland, from Wrocław University of Science and Technology, so again another type of climate, and from Spain, south of Spain, from Cartagena, the Universidad Politécnica de Cartagena, the Faculty of Agricultural Sciences. The project is founded under 2021 joint call on circularity. That it's a mixed call, joint call between ICT Agri-Food, FACE Eragas, Eranet Susan, and Suscrop. So we all these 5 partners come together, and we tried to find or identify and test some solution to mitigate greenhouse gas emissions. And for this, we first try to identify some synergy and complementarity with other sectors, try to find the most sustainable solution for each type of climate area. We develop already some ICT tools, and we already start. We have already in some places more than 1 year on testing and trying to validate the project solution. And to be sure about the effectiveness of our solution, in the end, we have some LCA approach to estimate and validate our solution from the environmental point of view. So as background information, and also to have a view about how we fit as a group in the European type of farms, you can see here that at the European level, more than half are as farms are working in are crop specialists, livestock are 21, and only 90% of farms are working are mixed farming. And from this, for the total, you can see at almost, let's say, 10% include various crops and livestock combined. If we take a look of how our consortium, the country in our consortium are distributed this type of farm, first we can see that Poland, together with Romania and Spain, with a small portion from contribution from Finland, acknowledge more than almost 16% of farms. With Romania having around 1/3 of the number of European farms. That means not necessarily that we are a very big producer, but also that our farm dimensions are very small. Also, this happens partially in Poland, and because we both are from the East European, these have some historical background. As you know, Poland and Romania are former communist country, and let's say there are some historical changes, so that green revolutions that my colleague presented before have a different, let's say, history in the east of Europe. And after the changes in the Eastern Europe in 1990, what happens is that the fields, the big farms that are formed by the communist regime are fragmented, splitted in many small farms, and many of them start to become, at least in Romania, are mainly mixed farms, because they grow from directly as a local need. Was built like a local need because it's, let's say, some history here. Okay, so if we look to the way that these farms are splitted in between the country, our country in the consortium, we can see that from Finland, the farms are mainly in the specialist cropping, with some livestock, and the mixed farms are very low as number. It's 3.5. From Poland, it's a little bit different different splitting. The specialist is also the highest one, is 65%, livestock 12, but mixing it's around 21. Spain, it's more or less the same distribution as Finland, with cropping 78, specialist livestock 40, but mix it very, very low. In Romania, it's different type of case, more close to the Poland, but with the mixed farms in higher numbers, almost, let's say, 1/3%. So in this context, we try to develop our project and try to exchange between us views and, let's say, experience from the field, and see how it's better to increase the circularity between, let's say, livestock and arable and land use. So we proposed in our project 3 pilots. The first one, which is in Romania, is to explore the management option to mitigate GHG emission in the mixed crop livestock production system, and we will use and develop a decision support system for this type of management in order to mitigate emissions. The second pilot, which is in Spain, was focused more on evaluate potential of regional synergy between livestock and crop production. So in this case, they try to increase the exchanges between these two types of production. And they explore the new management option to enhance agro-system circularity based on regional synergy between livestock and production. This will be a potential result. And the pilot number 3, it's a collaboration mainly between Poland and Finland. with the aim to test new solution to increase circularity. And that means that they propose to develop some new type of fertilizer, biofertilizer, that will be tested both in Poland and Finland. Overall, as I say, we also will have a life cycle analysis for all the pilots. Okay, so now I will present a little bit how we design the first pilot and show some preliminary results. First, we started with the conceptual model about what is a mixed farm. We have a pilot in a farm in Romania, where we take the data for them, and we have their collaboration to do some changes in the way that they manage the current the way that they currently manage the farm. After that, we start to develop an information model for the mixed farm. We have the splitting between input and output data because we need to develop some kind of platform for the management and assessment of greenhouse gas emissions and solutions. We split it between estimation of GHG emission from direct emission, indirect emissions, from emissions from enteric fermentation, manure management, from plant cultivation, energy-related emissions, including the use of biogas. Also, we included some air pollutants and the way to monitor other environmental parameters like water consumption, waste, and so on. We develop a model, and we also do a lot of measurement in the field. And as output data, we select different type of indicators. Next step was to really develop the platform with we have, as you see here, a diagram of the entire architecture. We go to the farm and install the various type of sensors. As you see here, it's my colleagues with the laptop and the cows. And in the end, we develop the platform, an ICT platform, which include an emissions calculator, a dashboard where you can see also the air pollutants and a pollution dashboard. The platform includes some features, including like possibility that you can compare your results with your previous estimation, compare also possibility to compare with other farmers that can use this platform, and of course split it between the different type of let's say split it on livestock, on type of process, on plant, to have an idea about the emissions. For this pilot, for the data in from 2022, we already elaborate an LCA. First, for the linear system without trying a solution to increase the circularity. We already have some results that show that mainly the GHG emissions are from the main impact is from the synthetic fertilizer with almost 84%, and I think more details and the exact calculation and the entire LCA will be presented in a paper that we expect to be published somewhere in the first months of 2023. Okay. The next step is mainly the next pilot that we try to implement. It's the one in Spain that try to find the synergy between the horticulture with the ovine cattle. Ovine mainly they try to use the one that it's about lamb used for for lamb meat production, and also to assess the benefits and feasibility of replacing synthetic fertilizer with local livestock manure. For this one, we also start to use the livestock waste, the LCA, for the use of livestock waste for compost versus the use of peat with synthetic fertilizer. Another experimental trial to increase the circularity, it's the one that we try to have two types of production of the greenhouse rocket. The first one, we analyze two types of system. The first type of system, it's the conventional one with the greenhouse rocket salad production, and the other one, it's a combination with the greenhouse house rocket salad production that will use some local oven compost, and with reuse for part of the water or drainage for salicornia and sea fennel production. You can see here some a picture for the testing field for the greenhouse, because it's about a greenhouse, and of course the diagram with the circularity and all the flow between different type of fertilizer or let's say inputs like renewed water, drainage, all the circularity that we propose. The last one is the work performed mainly in Poland, and with the help of testing with the help of partners from Finland, and they were more focused on production of some new type of fertilizer, but having as raw material, they will start from ashes from sewage sludge incineration, plus some anaerobic digestate in different type of technology with various, in fact, type of technology, because they need to solve some of the limitation that already you know from, and was also presented by my colleagues previously, like concerning about biosecurity, and the part of another one that it's more specific when we work in this field is about the content of heavy metals in this fertilizer. So till now, they succeed to proceed some solid fertilizer and also liquid fertilizer. They have the first, you can see the first results, and we already have the test on plants this year. For starting with the germination test, the pot test, and then with the field test over the summer. And you can see that in the last few figures from here, the first row, it's without the using, is the result without using this type of fertilizer, solid fertilizer. The second one, it's with the fertilizer. The tests were made in Poland, near to Wrocław, to the institute in the field. And for the next year, they will be also tried in Finland in the field. Because till now they make some tests only in just small tests in laboratory and some chemical, more or less. So seems that the results are very promising. We'll have, based on the results on the field, we'll also assess with the help of the LCA the effectiveness of these solutions. And everything will be published. Till now, anyway, the Poland partners, together with, we have also some cross-collaboration, will have, I think, a high number of papers already presenting this technology and results, and we expect that somewhere in the September next year to publish. We propose as a project level to publish a book with all the solutions, testing, and results. Okay, thank you for being here, and I would like to thank you from the part of our entire consortium.
Thank you very much, Dr. Balanescu, for your presentation. Thank you for sharing all the results with us. It's very interesting to see how history actually plays a role and how the crop systems are established and how they evolve. I have a question. Where is my question here? Oh yeah, remind everyone, if you have questions, you can put it in the Q&A or in the chat box. That the software that you developed, is that going to be available like for farmers to use?
Yes. Our idea was to start first, we develop in both in English and in Romanian. Okay, we started with both versions. So we'll start first to try to use more intensely in Romanian in an association of farmers to see how they work, and after that, yes, of course, will be open.
That's great news. So I have a question here from Marc. It says, is the number 3 feedstock from animal waste? But number 3, I'm just trying to wonder if you can elaborate that question. Well, maybe while he writes down. Do you understand like what he's asking? Is the number 3 feedstock from animal waste in the Q&A section?
The 3 feedstock from, yes.
Okay, yes, okay. And how have you seen kind of the panorama, because you've been working in this topic, how have you seen the panorama of mixed farming system? How has it evolved in the last 5 years for what you have experienced?
From let's say from Romania mainly. Because here we have a lot of mixed farm. There are different pressure for this, because they are small mixed farm, and one of the pressure is about the finance. The second one is about the human resources. Being small means that you need to have specialists. It's difficult to manage. So mainly it's about mix. These are the challenge about the finance. Also in Romania, in the last let's say year, a second problem was the war in Ukraine, and because a lot of transit from agricultural products came from Romania, that means that part of the transportation start to become for the local producer with more prohibitive, in meaning that the price increases very much for the transport, because the request is high for transport, and in this way make all of them to be very concerned about the future in this view. They try also to orient and a lot of going into the market with the part of organic farming. It seems that could be a niche to develop, and the fact that they need a lot of collaboration to go to the market with their products. So they don't have the financial power alone to go to the market, to the big market. So they need to invest more in cooperation and collaboration with also with other entity, and reach the market to be able to ensure the sustainability. So let's say these are could be main concern for them.
Yes. How do you think maybe what policy frameworks can support like mechanisms that could encourage the farmers to to implement practices to mitigate the greenhouse gas emissions?
Already, let's say, as a legal framework for this, they are already in the Common Agricultural Policy. There are some points that sustain this, some recommendation mainly, that sustain this use of different techniques and encourage the mixed farming. I know that there are discussion about establishment of more or less a kind of similar with a similar system with emission trading scheme, or different type of carbon pricing for carbon stocking. They from our discussion with the local farmers, they are interested in any way to increase the finance, because I used to say they are small. They are really small. There are many and small.
There's a way to go, like a long way to go there. And we're reaching 10:03, so I guess it's time for me to close the seminar. So thank you everyone for your questions. And I would like to thank once again to Dr. Moraine and Dr. Balanescu for giving us like wonderful insights of their presentations and an overview of their respective projects. And so this is our last webinar about circularity in agriculture, but there are so many things to explore that I'm probably gonna revisit another session for circularity in agriculture. In the meantime, for next year, we're gonna focus on the new series, which is going to be on biotechnology to advance sustainable solutions for bioeconomy, where we are going to explore topics related to, for example, plastic degradation, production of chemicals in a sustainable way, biofuel production, protein engineering, and more of these topics. This webinar series is going to start on January 10th at 10 a.m. Central Europe time. And our presenter, we are going to have two presenters. The first one is going to be Professor Tim Bug from University of Warwick, who's going to talk about microbial conversion of lignin to monomers for bio-based plastic using synthetic biology. And Dr. Jose Jimenez is going to share with us how the microbial interaction of plastics in the circular economy could work. I really hope you enjoy this series of circularity in agriculture. And I hope I'll see you next year for our next series. And again, thank you very much for my panelists. I really appreciate it. I really enjoy doing all of this series. And I'll leave it to, I have a great day today. So thank you so much. And I'm going to close the seminar now. Bye-bye.